to review the cell-based model of coagulation. Due to a delicate balance between the procoagulants and the anticoagulants, blood stays in the fluid state in the body. When there is trauma to the blood vessel wall causing a breach in the endothelium, the coagulation cascade is activated. The outcome of this process is to develop a clot at the site of injury to stop the bleeding. The process also ensures that the clot development is limited to the site of injury of the blood vessel. As soon as there is a breach in the endothelium, tissue factor-bearing cells are exposed from the subendothelial tissue to the bloodstream. The tissue factor is anchored to the subendothelial cells via a transmembrane domain, and it acts as a receptor for factor VII. Factor VII binds to the tissue factor and is activated in the process. Simultaneously, soon after the injury to the blood vessel, platelets reach the site to produce the primary hemostatic plug and become partially activated in the process. The tissue factor activated factor VII complex catalyzes two very important reactions: activation of factor X and activation of factor IX. The activated factor X formed on the surface of tissue factor bearing cell interacts with activated factor V to form prothrombinase complex that generates small amount of thrombin. This small amount of thrombin produced on the surface of tissue factor bearing cell is sufficient to initiate events that prime the clotting system for subsequent thrombin burst. Tissue factor pathway inhibitor helps to restrict the activity of activated factor X to the tissue factor bearing cell surface. The small amount of thrombin generated on the tissue factor bearing cell plays a critical role in priming platelets for subsequent steps in coagulation, such as activation of platelets, release of factor V from the platelet alpha granules and its activation, activation of factor VIII and its release from the von Willebrand factor, and activation of factor XI. Factor IX generated on tissue factor bearing cells reaches the primed and activated platelets where it binds to activated factor VIII. This activated factor VIII and IX complex activates factor X on the surface of the activated platelets. The activated factor X and V convert prothrombin to thrombin. This leads to the thrombin burst that drives the entire coagulation process. Thrombin converts fibrinogen to fibrin, which forms the structural meshwork that consolidates an initial platelet plug into a solid hemostatic clot. Once a hemostatic clot has been formed, it is protected from fibrinolysis by the action of factor XIII and thrombin activatable fibrinolysis inhibitor. This brings us to the end of this module. Thank you for watching.